Good evening, ladies and gentlemen. Thank you very much for giving me a screen. My name is Gawel Solosky from Bingo University. I will present today my uh, another perspective of hydrogen production, containing more based on phytocatalysts. Because the article mm, the article was written by Professor Banerjee from Kuala Lumpur University and Seoul. And this is, to say, about review newest possible methods of hydrogen production, basic of biomass. The Professor Banerjee proposed three methods as for bio-waste. First, by using photocatalyst, then anaerobic fermentation, and using heat by pyrolysis, or she called by gasification. He doesn't talk about microbial methods, which causes an electrolysis. He doesn't also mention about mechanocatalyst. He only on three methods basing because he fits as the most important now and using light. The first part is huge review of photocatalytics and graphene, and this in case he calls because photocatalytic is using sun energy to split water and other waste, also bio waste, to break into pieces. He compare to pyrolysis and gasification, or more to gasification, but without such side effects, because gasification produces lots of oxygen compounds, oxides, which are quite toxic, and therefore this is the trouble of gasification. In case of splitting of biomass by means of photocatalysts, we don't have, and especially with this compared with graphene. This photocatalyst proposed because some are iron oxide, which are very important, and nickel oxide, after using to can be intoxicated because photocatalytics have some lifetime, can be transferred into dark fermentation reaction because these compounds are very important nutrients in case of dark fermentation. Dark fermentation here is called anaerobic digestion, as it is the other method recommended by Professor Banerjee because it uses much more waste in uh, much more waste variety in less dependent from sunlight and from sun radiation, sun sun conditioned production, which can be also used during night. And the enzyme works in splitting of simple organic compounds in natural ways into butyric pathway or acetic pathway, and these compounds, by breaking glucose and pyruvic cycle, producing energy. This hydrogenases using some enzyme which are nickel or iron hydrogenase, which contain iron and nickel. Therefore, adding some nickel iron nutrients helps in production of hydrogen. This a general phase because these methods, photocatalysis and dark fermentation, don't require as much heat or gasification and no such gases like nitrous oxide or sulfur oxide, because conventional not is as fatty less, but still quite low when fossil fuels that are remedial biomass that stands in the earth and the earth crust, some billion layers, which are depleted because our uh, reserves of this primordial biomass was used and combusted, and now this combusted organic matter grows as carbon dioxide bubbles, increasing and causing greenhouse effect, and other is using materials which is plastics, which also is new place. So these methods both can reduce these two troubles and use some waste. And he using water splitting as mostly using because it split also after energy like pyrolysis, but sun is shining on this photocatalytic and which contacts with water on other biowaste and splits. Therefore, it is the proper way. And in case of dark fermentation, he shows that these two methods can be also produced because we have from lignocellulose, which is the most important plant agriculture waste, because its leaves of straws and waste of agriculture can be by gasification, also by water splitting, and can be other pathway by first by dark fermentation or fermentation, which produce kind of ethanol, which then after photoreforming, so photocatalyst can be easily split into hydrogen because it's such pathway. Another pathway is organic acids like acetic and butyric that can be also. So he proposed, Professor Banerjee, that combine two methods, photocatalyst and dark fermentation, to higher efficiency of waste decomposition into simple organic matter. So again, to the composition that can be easily absorbed and by nature, by surrounding, without polluting it. The gasification requires also some catalysts, nickel, palladium, and platinum, mostly, which has to be are very expensive and are toxicated. In photocatalysts, some of them are photocatalytical, but not so easily toxic poisoned, because catalyst has some lifetime, which is much lower than enzymes. Which enzymes, which are in using dark fermentation, are in fact also catalysts, but much more resistant and more can be using much more times, which is the another advantage of dark fermentation. Therefore, the list of photocatalysts is as the most is titanium oxide, which you can use also as paint in white. It is as white used also as paint and it is as food addition in some countries. However, in Germany, it's forbidden due to some research that can cause cancers, increase risk. And in Poland, you can use titanium oxide, while in Germany, you cannot use in case of food or pharmaceuticals. And the most important are, according to Banerjee, is titanium oxide and silicon oxide, which can easily be easily be cheap and easily can break the waste, mostly on water, but some also on sugar, which will be undigested in case of dark fermentation. A chance of it's very high in case of methanol and methanol solution, which is very important because it can be used in the waste of furniture, because methanol waste are big trouble in case of paintings of wood industry. So after this furniture industry waste, which are very dangerous, can be easily broken due to photocatalyst. And also some bacteria occur but not producing hydrogen, so not producing something extra which can be more easily suitable for bank, because bank wants to have sponsor business that have many possibilities of benefits. And other are glycerol, which is quite high but lower than ethanol or methanol. In case of anatase, is much higher than in case of other of routine, or brucite. And this is it. In case of dark fermentation, he recommends the cotton using as the highest, using my research. But still, in case he doesn't show that it's very difficult still to as cotton. However, it's only containing cellulose. It's very crystalline path and very hard to destroy and break this bonding, this cleavage. Cleave this cellulose into carbon to the glucose. So maybe this modified method that is now in some Vienna Institute research can be the solution. But this method shows that there are other methods, not only photofermentation, not only microelectrolysis cells, but also photocatalytic are in the game, review and science, to help us to replace our conventional methods of hydrogen production and other of fuels. Thank you very much for listening to me.